That is always termed as what? That angle, that is always termed as cos theta. Whenever you have normal reaction, that is made with the angle. Fine. So if this vector is making an angle theta with this axis, then it means you will get the component of cos here. So this becomes n cos theta. And perpendicular to this becomes n sine theta. Clear? N vector has been resolved into its two components. Now frictional force is like this. And this also angle will be theta. As I've told you, this is alternate. These are alternate angles. So this becomes, this side, this becomes f cos theta. Why will this be f cos theta? Because the angle is made with the x-axis. And perpendicular to this will become f sine theta. Understood all the resolution of vectors, and you have mg already downwards. Now see, here, which force according to you will provide the necessary centripetal force according to you? Which force? Because I have resolved the force as well. So if you think a component will provide, let me know which component. Centripetal force, which is mv square by r. This is equal to what? Yes, class, try look in the figure. According which force are you able to notice? Characteristics of centripetal force that we had studied was, firstly, that centripetal forces always acts towards the center along the radius. So according to you, which force do you think will provide the necessary centripetal force? Nobody. Yusuf, can you try? Maha? Aisha?
Centrifugal force.
No, centripetal force is there. Out of all these forces which you are able to see, f sine theta, n cos theta, mg, f cos theta, n sine theta, this frictional force, this normal reaction, so many forces are there. Which force will provide the centripetal force?
N sine theta.
N sine theta, good Aram. I think Aram has answered. Only Aram, n sine theta. Only n sine theta is correct. I'll write down here n sine theta. Now can anyone help her out? Only n sine theta.
F cos theta.
F cos theta as well. See class, these two forces are acting along the radius towards the center. No, if this was a complete circular track, we have just taken a part of this track. No, this is a complete circular track. From there, we have taken a part of it. So if any force is coming towards this direction, and that is pointing towards the center along the radius, that will be equated to centripetal force only. That's what was required from all of you. Now clear to all of you or not? To others who were getting confused. This is n sine theta plus f cos theta. All right, this is the necessary centripetal force. And this frictional force can be written as mu n only. So mv square by r is equal to n sine theta plus mu n cos theta. Now in this equation, you can easily see n is common. Let's take n common. And even before, let's take n common, because here n will be used. Sine theta plus mu cos theta equal to mv square by r. Now leave this as it is. Now see n cos theta. N cos theta is balancing two forces, f sine theta and mg. So how can you write n cos theta? Now you will write n cos theta. N cos theta is f sine theta plus mg. Y-axis, I have just equated all the forces above y-axis to the forces that were below. Now what will be the value of n from here? N cos theta. N cos theta is there already. mg. All the like terms together. So from here, only sine theta and sine theta are like. So n cos theta minus f sine theta is equal to n mg. Again, this becomes mu n. So n cos theta minus mu n sin theta is equal to mg. Let's take n again common. This becomes cos theta minus mu sin theta equal to mg. Now you have two equations. This is the second equation, and one equation we had already calculated. This was the first equation. Now you divide both of these equations. If you divide these two equations, so that becomes mv square by r is there, and you have mg in the denominator, means mv square by r term, that is mu cos theta plus sin theta divided by, here we have n, right now only we had calculated cos theta plus mu sin theta. No, not plus, we had minus, no, in the second equation. So m gets cancelled, n gets cancelled. Formula of velocity becomes c class what? Rg r into g, Rg mu cos theta plus sin theta divided by cos theta minus mu sin theta. This entire term, not only this entire term, since it was v square, so this becomes under root v. So this is the final formula of velocity. It was just mu rg in a plane case. As soon as it is inclined, it becomes under root rg mu cos theta plus sin theta divided by cos theta minus mu sin theta. This is a big formula. You have to remember this formula. Even in your 10 years previous year question papers, this type of question is there most in the half yearly exams that were conducted in different schools. Check your school pattern, how much have they completed this part in your schools, but this is an important formula because derivation is there. Derivation is not very difficult, so derivation is there of it. Okay, quickly note it down. Then we'll just do bending of cyclist, a very small topic, and we'll start with work, energy, and power. So note down this topic. This you have done from here.
Ma'am,
Yes, Aisha.
ma'am, can you explain the derivation again?
Yes, yes. See, this you have understood, resolution of vectors.
Yes, ma'am.
Okay. See, centripetal force will be provided by, as you have only answered it perfectly, F cos theta, and the way Aram said, N sin theta, because both the forces are pointing towards the center. From this equation, we had found the value of N sin theta plus mu cos theta. Fine, from here. Then second equation I have derived from this. N cos theta is actually equal to F sin theta plus mg. Y-axis, if you balance y-axis, this will be your answer. So from there, I had written N cos theta is equal to F sin theta plus mg. And somehow I got the value. Since I want to cancel n, no, I know my answer is not in terms of n. So I want to cancel n, and even the first equation that I have written already involves n. So I have shifted F sin theta, put the value of F as mu n, and got mg. Now n is also again taken common. Now using these two, first tell me, steps till these two equations are clear?
Yes, ma'am.
Okay. Now simply I have used these two equations and I have divided them. So once I'll divide these two equations, from here, gets cancelled, Rg is left, V square is left, and this part. Sin theta plus mu cos theta was there, and right now only cos theta minus mu sin theta. Got it?
Yes, ma'am.
Okay.
Ma'am,
Yes, Aram?
derivation part is deleted this year.
Okay, this derivation part is not there in your school. It has not been done.
Yeah.
Okay, okay. Then just look at the formula. Usually from this part, no, the sine theta or the cos theta, theta's value is not difficult. That is asked. A known value will be asked to you, like 30 degree, 60 degree, like these values will be asked to you. Okay, one last topic, that is bending of cyclist. So that also derivation we'll do. Derivation is very easy and very small. Formula you have to remember, and directly the way formula based questions only will come from here. Bending of cyclist. You just have to remember which component will provide you the centripetal force. Once you are aware of which component will provide you the centripetal force, derivation becomes easier. So see, if a road is there and a cyclist has bent himself, let's say this is the direction of cyclist. Cycle moves in a straight path, but now as a turn came, the cyclist turned himself. He bent himself in such a manner. Okay. As soon as a turn came, he was riding the bicycle straight away, cycle straight away. As soon as a turn came, he bent himself towards the one side basically, that is towards the turning side. If it is towards the right side, let's say, so he will bend himself towards the right side. If he's moving towards the left, he'll bend himself towards the left side, like this. So that is bending of cyclist. So this becomes the normal reaction because this is the contact with the ground. If the wheels of the cycle, they are like this, if you look at it from this position, they'll appear like this. Rest of the cycle and the parts of the cycle, whatever are present, that will appear to you like this. So if you look at it from here, this part will be providing to you the normal reaction. No, so this becomes the normal reaction. Again, we have to resolve this. So see, if you take away, let's say we have taken some angle theta on our own, we have taken, and here downwards is the weight. So this component, this becomes n cos theta, and this component becomes n sine theta. Now tell me one thing, which component according to you will provide the centripetal force? Yes, class.
N sin theta.
Okay, good. Aisha only answers this part. So I think centripetal forces concepts of Aisha has become clear. N sine theta provides the centripetal force. This is n sine theta is equal to mv square by r, right? And if you see n cos theta, what do you think n cos theta is equal to? Look in the figure.
Mg.
Mg. Good, Aisha. This is equal to mg. Take their ratios. So n sine theta, this becomes equal to mv square by r. This is n cos theta. This is mg. N gets cancelled. M gets cancelled. Sine theta by cos theta is tan theta. So this becomes tan theta is equal to v square by rg. V becomes equal to under root rg tan theta. So for a cyclist, this becomes the safe limit. All right, this was a small, easy, but last part that was left from this part. Then we'll start with work done. Work energy power we have to start. Note this down. Any queries you have from this lesson, let me know. For the students who have joined C class, you or most of you have joined from the circular motion. Hiba, is it clear to you, this part? Hiba, clear? Okay. Tell me, class, one thing. You all have Saturday classes, no? Mathematics class or something on Saturdays. Or is your Saturday free?
Yes, we have Saturday math class.
Maths class, you have it. All right. Because we have to have at least one class for the backup. Differentiation, integration are very basics for the upcoming lessons as well. In work energy and power also it will be used. So that's why. Okay, let's see. Let me see who all have joined other classes. Okay, let's do one thing, class. Since this chapter has been completed, other students who were there from the beginning, you all already have the notes before the circular motion part, and many students have the notes for the circular motion part as well. Go through this lesson. It's 20 over right now. After 5 minutes, I'll ask if you have any queries. Just go through the pages, turn the pages, see if you have any queries. Take 5 minutes. It will become a break also for us. And then we'll start with the new lesson once you've completed this. Yes, class, I think sufficient time is there. If you have any queries, any doubts, you can text me also right now. If you have any doubts from your this lesson, then we'll start with work, energy, and power. How much is this? Okay, from here, if you're asking from friction part separately. Now, from frictional part separately, the questions will come if you're talking about inclined plane. From friction part, it will come, but you have to resolve it. Mainly, that part is included in work energy power. In today's class, also, we'll see certain questions where it will involve your inclined plane. So, inclined plane problems separately are not there. Resolution of vectors are there. The way pulley problems I was telling, I was mentioning to this to Maha and Aisha Neram also, Abdullah, you were there. So, you all know what I had told that time. Work energy and power in other lessons, not even in work energy and power, in your rotational physics and all these lessons, that time it will be included. But if you see it separately, then separate question that has already been deleted, so do not worry about it. All right. Yeah. Okay. If you're asking separately about it, the 3 Newton's law that can be mentioned to you. 3 Newton's law mentioning will be there. Derivation for the second law will be there. See, second law, Newton's, all the 3 laws are very important. So that will be there. The 3 laws in your theory questions will be there. From the 3 laws, each of the topics that are done. And we have discussed all the topics as well, separately only. So momentum and all these topics, impulse, all these topics will be there. So yes, do not worry about it. All these topics will be there. Fine. So any other query? I think let's start with work, energy, and power. Only half an hour is left. C class, again, same things. Basics will again be used here. Dot product will be used, especially dot product more than cross product. Dot product will be used, differentiation, integration will be used. Here we use mostly integration and dot product out of all the basic physical, mathematical physics that we have. So do not worry about it. Those who are weak in differentiation or integration, or those who do not have so much idea about it, we'll arrange a class for you all. Last Friday, the class couldn't occur, and Saturday, I was not aware about your timings. Class, Saturday is a holiday, no, for all of you at your places wherever you're residing. Saturday is also holiday, no? Like Sunday is working.
Yes, ma'am.
Saturday, you all have Friday and Saturday as well. Yes or no?
Yes.
Okay. All right. And what about you, Waziha? Waziha, I think here in Delhi. So in Delhi also Saturdays off. You're here only, no? In Delhi, Waziha.
Yes, ma'am, but my exams are going. That's why this Saturday is not free.
Okay, this Saturday is not free. It's working. Otherwise, you have your Saturdays off, no?
Yes, ma'am, but my exams were going till 4 September.
Okay, 4th September.
I mean 4 November.
4th November. Okay. Okay. And what are the timings? Like, at what time do you reach back home? At what place do you stay?
Mummy,
Yes, at which place do you stay?
I stay in Malvinagar, Hosrani.
Okay, okay. So, at what time around do you reach your home?
1 o'clock I reach my home.
For this exam time, I'm asking. 1 o'clock?
Yes, ma'am.
Okay, class. So that class thing, firstly, I'll get the timings of your schedule because I myself do not know the timings for your mathematics and all classes. So most probably on Saturday, I'll try to have a class before the other batches classes are there in the evening and the classes begin, because we have to have certain classes. Otherwise, these backups are also there in your syllabus. Projectile motion is there now. Laws of motion has already been added. All these backups will get by it only. So it's better if slowly all these basics are clear. All right. See, work energy in power, this is a short chapter I'm telling. This is not as lengthy as laws of motion. Work energy in power is not difficult also. Basically, force you have studied till your laws of motion. Quantities just get added up. Like you had the very basic quantity as dimensions in the first lesson. And after dimensions, when you reach motion in a straight line, you had few quantities regarding velocity, acceleration. Now, motion in 3D came, then it added it to it. After addition to that, then you had force, which was mass into acceleration. So already the students who already knew about acceleration could only know about force. Now students who know about force can only know about work done, because work done is nothing. It's just dot product of force and displacement. Dot product of force and displacement. So dot product, we have seen work done will simply be force and the dot product of the displacement it has occurred. For example, if I say a block is there of mass m, right? Some force I have applied. Some force I have applied to this block. Let's say it is making an angle of theta with the x-axis, but I have applied some force. So due to application of the force that I have applied to it, the mass, this block of mass m moved forward. So there was a displacement that was observed. This work done will be equal to F dot S, which we say, or magnitude of force multiplied by magnitude of displacement cos theta. How I have written this is simply the formula of cross product, dot product. In dot product, if you take the dot products of any two physical quantities, then how do you solve it? You take the magnitude of the first quantity, you take the magnitude of second quantity and multiply it with cos theta. All right, so work done is F dot S, which is Fs cos theta. Simple definition is there. And why this lesson is much simpler is because this is not a vector quantity. Your work done is actually a scalar quantity. This is a scalar quantity. So as soon as any of the quantities become scalar, no, the limitation of solving all the parallelogram law, triangle law, all these laws, because vectors are not solved directly algebraically, they cannot be solved. So now here, since work done is scalar, one big load of yours becomes easier. You just have to focus on the magnitude. Direction, you're not so much concerned with the direction. Otherwise, in force, you had to see when you had force, you had to check in which direction the forces are moving. Are they making an angle of 90 degree, whatever is the angle made between them. Similarly, for velocity also, motion in a straight line, relative velocity also. And also like this, you had all these topics. So if it is work done is scalar, so basic questions are there from work done. And yes, class questions, especially for students who have to appear for their entrances after they've completed class 12. Right now you all are in 11th, but you must be having certain goals as well, whether to appear in JEE or NEET. So even questions, especially in NEET, these types of questions come from work done often. Work done, simple questions from work done. Because questions from work done are mainly from this part. And in JEE, the level gets a little high. There's not much difference in this, but integration part becomes a little more mathematical. That's the difference that arises. And SI unit is important to remember. SI unit, when we were discussing dimensions and units and dimensions, I had told you this is joule. Fine. And CGS unit. CGS unit also remember, because you have to perform the conversions. It is ERC. So this is the SI unit joules and this is the CGS unit ERC. Now how to convert it? 1 joule is equal to 10 to the power 7 ERC. you must be remembering it. We had done a question also in units and dimensions, which proved the fact when we use N1 U1 is equal to N2 U2. From there, we had derived this relation as well. This relation as well as I think Newton's and Dyne's relation. So 1 joule is equal to 10 to the power 7 erg. Simple question will be there. Let me show you a question, how a question comes from this part. And yes, class, I do not know about Monday. I have no information yet. If on Monday, because of Diwali, we have a holiday, then we'll not be having class on Monday. You'll be having your test on Wednesday. But if just in case we have the class on Monday, which I think will not be the case, but if we have the class on Monday, then you will be having the test of only circular motion, not the complete lesson. And I think Hiba is the only one who has joined late. Other students have attended. So Hiba, just try. If you think you are comfortable, you will be able to manage with the test. Please study circular motion. Take the recording from me. Take the notes from me. All right. So I wish and I'll suggest you to appear for the test. It will be a class test. Okay, let's take an example. Let's say force of 10 Newton acts on a body and it gets displaced by 5 meters. If force acts at 60° to the displacement, calculate work done. I think this is the easiest question that is possible. I hope you all can also try this. Take 2 minutes, try this. Okay, do one thing. Firstly, note this part and then try this question. Note down this part, and as you will reach that part, note it down. So this is your chapter 6, work, energy, and power. Chapter 6 of NCERT. Yes, Aram. Good. Answer also you have completed. It's correct. Others also try. Direct formula based question it is. So correct answers have been given by Aram and Maha. See, there's a slight error in your answer. Now see, it says what? F is given as 10 Newton. Your work done is now F is cos theta. So force is 10 Newton and S is 5 and you have cos 60 degree is half. So this becomes, I think you've forgotten this half. So this becomes 5. 5 into 5 is 25 joules, like this. Now see, questions can be in any form. You can have the simple questions in Cartesian form as well. In work done, this is the only concept that we have in work done. Like for example, if I say force is given as 2I cap plus 3J cap plus 5K cap Newton. All right, this is the forces formula that is given. If I say a body's initial point is, let's say A point is 3, 2, 1 and final point is 2, 1, 1, let's say. This is point B. So it means initial position vector is what? 3I cap plus 2J cap plus K cap. 3, this is I cap, this is J cap, this is K cap. So 3I cap plus 2J cap plus 1K cap. Similarly, I, J, K. RB becomes 2I cap plus J cap or plus 1K cap. You can write 1 as the coefficient or you can leave the answer as well. What's the displacement? Displacement is final point minus initial position minus initial position. So in such cases, if you have, if students were not able to understand, it must be because of your basics, dot product, cross product, vectors, Cartesian form. So that we'll discuss. I'll send you the playlist also. Let me get you all added on the group. So if anybody wants the playlist, you can text me personally also on WhatsApp. I'll share my number with you all if you want. So it becomes RB minus RA. The displacement that will be here. This will be RB minus RA. So this becomes 2I cap plus J cap plus K cap minus 3I cap minus 2J cap minus K cap, because these signs will get changed. So 2I cap minus 3I cap. Here you have minus I cap. And this part is J cap minus 2J cap. So again, minus J cap and k cap gets cancelled. So minus I cap minus j cap is only left for, this is now the displacement, SBA you can write. And force is given as 2I cap plus 3J cap plus 5K cap Newton. So dot product between these two becomes what? Work done will be F dot SBA. This is minus I cap minus J cap dot 2I cap plus 3J cap plus 5K cap. So what did we study when we have the dot products in multiplication? Coefficients will get multiplied by the coefficients of the same term. Like coefficient of I gets multiplied with the coefficient of I in here. So here the coefficient is -1 and here the coefficient of I cap is 2. So 2 into -1 will be -2. Understood? Similarly, I'll write down this. Okay. Coefficient of I cap from here is -1. Coefficient of I cap is 2. So this becomes 1 into -2. Then you have plus. Then coefficient of j cap -1, coefficient of j cap 3, plus coefficient of j cap, coefficient of k cap. There is no k cap over here, so 0 coefficient multiplied by coefficient of k cap here 5. So we are left with -2 -3, that gives -5 joules. Clear? Note this down. Any doubts you have in here? If you are done till here, then you all can leave. We'll continue the next part of work energy and power in the next class only. All right, class. So be prepared for the circular motions test. A small class test. I'll have 2 to 3 questions only. All right. Thank you so much, class. Take care. Goodbye.